In today's lecture, we will be discussing about regulatory guidelines for conducting stability studies for various products at different climatic conditions. This lecture includes the guidelines to carry out stability studies and what are the different types of stability studies that are involved, like long-term stability study, accelerated stability study, and what are the recommended conditions where we can carry out this type of studies to study the stability of pharmaceutical products. Now let's get into the lecture. To carry out the stability studies for various products, be it pharmaceutical products or cosmeceutical products, we have an organization which has set up few guidelines. So we have a council organization called the International Council for Harmonization. This council has given us few guidelines which are to be followed to carry out stability testing of the drug substances and even drug products. According to this council, there are few guidelines. What is the purpose of having those guidelines or the protocols? Because, as we all know, different regions or different continents, they have a specific climatic conditions. So based on this, most of our countries are divided based on the climatic zones. For example, few drugs which are stable in one zone, say for example, if we consider the climatic condition of Iraq or Kurdistan, the climatic conditions are different from other parts of the world. So few drug products might be stable at this condition, might not be stable in other parts of the world. So if we are supposed, we being a pharmacist, we need to consider the stability of a drug product across the globe. So for this, we need to make sure our product we should be able to withstand different climatic zones. Because, for example, if we are producing or manufacturing a drug product or cosmeceutical product in this place and we are supposed to export this product to other country, this product has to withstand the temperature of this zone and also that zone. So, based on or by considering all these climatic zones and various drug products, International Council for Harmonization has issued few guidelines. So, whereas the first guideline, which was released for stability testing of new drug substances, was in 1993. So, based on the different products and different guidelines, each guideline was given some code like QA, Q1A, like that. Now, ICH and WHO have collaborated and has set up few guidelines for stability studies. Now, let's see one by one. For example, the parent guideline, the very first guideline, Q1A, has been revised. Some additions for the new guidelines have been taken up, and it will be revised now and then based on the changes in the climatic conditions and based on the type of drug products. So, but then the parent guideline, which was released actually in 1993, has been revised to later the newer version Q1AR2, and this contains the requirements that are to be needed when we want to register for a new drug molecule, especially to the regions of in the regions of Europe, Japan, and United States. So this is about the introduction. So now let's see the guidelines in brief. ICH has given few guidelines to carry out stability studies. Now let's see in brief. So for example, ICH guideline Q1A R2 represents or gives the information about stability testing of new drug substances and products. Now we need to know the difference between drug substance and drug product. Drug substance is the pure drug molecule, and the product E means it could be a pharmaceutical product or cosmeceutical product which involves the drug molecule and excipients to get a defined dosage form. Whereas drug substance is a single molecule entity. So if at all if we come up with or if we invent or discover new drug molecule or new drug product, we need to follow the guidelines of Q1AR2. We need to check if what all we need to check for the stability of the new drug which we have discovered. We need to follow these guidelines according to Q1AR2. And Q1B gives the guidelines for photostability testing of new drug substances and products. For example, if the drug is photosensitive or not, if we wanted to know, we need to follow the guidelines. And these guidelines might include at what frequency we can expose the drug molecule or the drug product, at what like at what light, whether it is UV light or visible light. So based on the drug product, we need to check the guidelines and do accordingly. Similarly, for the new dosage forms, like for example, if we discover or invent like a new dosage form like transdermal patch or any new dosage forms, we need to go in accordance with the stability testing that is given in Q1C. And Q1D gives the guidelines of the designs, bracketing and matricing designs for the stability testing of drug substances and products. What is meant by bracketing and matrixing designs? Which gives the information about how long we need to do this stability test and in what way we need to carry out this test, at what temperature, at what humidity conditions, and how long we need to carry out this stability testing or stress testing. So the design of the study is well explained in Q1D guideline, and the guideline number Q1E gives the information of evaluation of the stability data, the data which we get from this test. How can we evaluate? The standard values will be given, or how to evaluate the data that is generated by this test will be given in Q1E guideline. And Q1F is about stability data package for registration application. For example, if the given product is being stable, and now how can we go further, like registration of the particular drug molecule or the product, especially in the climatic zones of 3 and 4. We'll see what are the different climatic zones. So likewise, we will be having many guidelines, out of which for pharmaceutical purpose it is Q1A, Q1B, Q1C, D, E and F are much useful. Now how? I'll just give a simple tip for you to remember what are these guidelines about. For example, Q1A is for new drug substances and products. B, photo stability. For example, D for design of the study. D stands for D. E stands for evaluation. Like that, you need to remember. Of course, the first two stands for the new drug substances, photo stability, and the dosage forms. And F is with the registration. So these are few guidelines that are related to our field. Now let's see, what are these climatic zones about? Are these really important? Yes, because if we are supposed to manufacture drugs or drug molecule or drug products, and if we are supposed to export these products to other countries, we need to check the stability of the products in this region and in the region where we are ought to export. So as per ICH and WHO, the globe has been divided into 4 zones based on the annual climatic conditions. So we are having basically 4 zones. Zone 1, temperate zone. Zone 2, subtropical with possible high humidity. Zone 3, hot and dry. Zone 4, hot and humid. So, pharmaceutically, if we are in the industry producing new drug molecules or drug substances, we actually speak in terms of zones. Zone 1, Zone 2, Zone 3, and Zone 4. Now, let's see what is the purpose actually. No, of this study, we actually do this to know the quality and the stability of the drug substance. We'll get some evidence if our product is stable in this zone. We need to check for the stability of the product in all these zones actually. For that, we cannot go into particular country and check for it. Rather, we can simulate the same conditions in the laboratory and we can check for the stability. And thus we can establish the shelf life or expiration date of the drug product, and thus we can actually recommend storage conditions. So this is the importance of climatic zones. Now we will be studying about the types of stability studies. The type of stability studies include long-term stability study, intermediate stability study, and accelerated stability study. In this picture, we are seeing stability chamber. We are seeing stability chamber. Now, let's see the beauty of the stability chamber. This is such a beautiful thing where we can actually simulate the temperature and humidity conditions. Here we are able to see some monitor, and these are the controls for the temperature, humidity. So in this chamber, when we open this, we'll be able to see different rows over which we can place our containers and set the temperature and the humidity values. Close the chamber for few days based on study time. So this is the normal chamber that we see in the laboratory, whereas in industry in large scale we will be able to see a largest chamber to carry out stability study. It will be very huge. So it'll be like a big room. You need to enter it. You'll be having so many chambers. We'll be putting all these containers for test inside, and then we'll be setting up the controls. This is about the stability chamber. Now, so based on what? we are having different stability studies. Let's see, based on the time period, we are having different study. For example, in long-term stability studies, so based on the guideline Q1A9R2 guideline, we will be carrying out long-term stability study. And how we need to carry out these studies, how long, and what are the different parameters to be checked, that we will be discussing in this guideline. Now, WHO defines long-term testing it as this long-term testing is defined as real-time studies by WHO, because here as such the drug product is being exposed to a normal storage conditions which are supposed to be intended to be in the market. The same storage conditions are actually maintained, and it is supposed to be for longer time. So hence it is known as long-term stability study. It is also known as a real-time study because we are not shortening the study time period. Now let us see what are the recommended. So here we will be discussing about stability study. There are three types. The first would be long term, and the second is intermediate, and the third is accelerated studies. Now let's see one by one. Long term, the name itself indicates the study time would be a longer time. Say for example, the duration of the study would be for 12 months, nearly 1 year, and based upon the product. For climatic zones of 1 and 2, the temperature should be, this is for a general case, means normal dosage forms which are stored at a normal room temperature. There are few drugs and drug substances which are stored in the refrigerated conditions, which are supposed to be stored at freezer conditions. So based on this, the cases have been divided into general case, refrigerator case, freezer case. Normally in general case, and that too for climatic zones 1 and 2, the temperature to be maintained is more or less nearly to the room temperature of 25 plus or minus 2 degrees, and related humidity to be maintained is 60 plus or minus 5. For 3 and 4 zones, because they will be dry, hot and humid, so the temperature to be maintained should be 30 plus or minus 2, 65 plus or minus 2. We need to remember these values. These will be really very important when we are getting ready to face some competitive exams for further studies. These are really important, and when we really work for an industry in drug development, it is necessary for us to know how to carry out and what are the conditions to be maintained during the study. And now let's see the substances to be stored at refrigerated conditions. So the temperature here, it changes to 5 plus or minus 3. For freezer, the temperature will be changed to minus 20 plus or minus 5. So now we have discussed about long-term stability study. Long-term stability study, their conditions, different cases, general case, refrigerator case, and freezer case. Now let's see accelerated stability study. The name itself indicates here we are exaggerating the conditions of temperature and humidity. Accelerated means we are speeding up the study time period. So here in long term, we have taken the study period time interval of 12 months, whereas here being it accelerated, the study time duration of study will be concise to 6 months. So now let's see what are the different conditions. For accelerate, we are accelerating the conditions, so the temperature would be 40 plus or minus 2 degrees centigrade, and the relative humidity is 75% plus or minus 5% relative humidity. And if in case in this 6 months time period, if we face any changes, if we see any physical or chemical changes in the drug product, like any significant changes during this 6 month, it is again exposed to 6 month study, but the temperature would be changed to 30 plus or minus 2, and here the relative humidity will be subjected to 65% plus or minus 5% relative humidity. So those studies are known as intermediate study. So in these accelerated stability studies, the drug substances which are to be stored in refrigerator should be maintained at 25 plus or minus 2 and relative humidity of 60 plus or minus 5%. Normally, it should be at least, the accelerated storage condition should be at least 15 degrees centigrade above the expected actual storage temperature. For example, if a drug is to be stored at 30 degrees centigrade, 25 degrees centigrade, then we need to carry out accelerated stability study at 40 degrees centigrade. Now let's see what is the testing frequency. Fine, we have placed our drug substances or products in that particular temperature and humidity conditions, but how can we do this sampling frequency? For example, let's discuss about the stability study, like long term. Normally it takes place in the duration of 12 months, for the duration of 12 months, and for few drug products it will be more than 3 years. The study would exceed more than 3 years. So for every 3 months, for the first year, in the first year of time analysis or study period, for every 3 months we need to take out the sample and we need to check for its stability. And for the very first year we'll be having 4 results for every 3 months, and at the end of this first year, from the second year, for every 6 months, so we'll be having 2 results. From third year we'll be having 1 result. Like, so if at all based on its shelf life, we will be taking out the sample and we'll be checking for any changes that have occurred chemically or physically. Similarly, for accelerated, normally the time period or the study period would be 6-month period. So it being 6 months, we'll be having 3 time points, like the initial, at the end of 3 months, at the end of 6 months. And the most important point to remember is the drug substances or the products where we are checking for the stability, they are to be actually placed in the final packaging system. The same container we need to use it, not just the glass beaker or not just the petri dishes. No, we are supposed to use the actual container. We need to place our product in the actual container, and we need to check the interaction of the drug product with its container also. So this is about the testing frequency and the conditions at which we are supposed to follow when we take up a stability study, be it long-term, intermediate or accelerated stability study. So if you're having any doubts, you can contact me through my mail. Thank you.